So good morning and welcome to the 2022 ONFARM Research Forum. My name is Bronwyn Wilton and I'm the Principal and Lead Consultant of Wilton Consulting Group. And my team has been happily supporting the Ontario Soil and Crop Improvement Association for the ONFARM Applied Research and Monitoring Project. Before we begin our program today, we wish to recognize the long history of First Nations, Inuit and Métis people in Ontario and show respect today to their traditional territory on which we live and work. We do have a jam-packed agenda for this morning, and the agenda was included in the forum information package and is also available on the ONFARM website. Andrea will drop a link for the agenda in the chat if you want to check in with where we're at during the morning. Mid-morning, as I'm sure you're all aware, we will split into concurrent sessions to take a deeper dive into either ONFARM soil health case studies or edge of field water quality case studies. Please do not worry about missing out on all the great content in the alternate concurrent sessions. A recording of today's forum, including the concurrent sessions, will be posted on the ONFARM website. My team will also create a summary report that Ontario Soil and Crop Improvement Association will share on the ONFARM website in mid-March. So I know when some of you might have been to the Laternal Symposium where you have to pick all the sessions, so right, we're aware people feel they might miss out sometimes, so we're covering our bases there. And just for some housekeeping items, we do have a large group here today. We had over 200 people register, which is really exciting and says a lot about the interest in on-farm research in Ontario. It's awesome. But just as we do have such a large group on a Zoom meeting, so it's not a webinar, so you all have capacity to speak and show your videos. So we'd ask you all to keep your sound and video off for the majority of the session, but there will be opportunities now and then, especially in the concurrent sessions, to ask questions. Our speakers will turn on their sound and video for their presentations, so you will see real people. And we also ask that you add your first name and last name or last initial your Zoom profiles so that we can ensure you are placed in the correct breakout room. So if anyone has trouble with that, send a note in the chat and one of our team will support you, but just make sure your name is correct and showing how you'd like it to in Zoom. We would also like to encourage you to use the chat box throughout the forum. Please feel free to introduce yourself in the chat and to enter any questions you have for the speakers. I will do my best to share as many questions as possible with the speakers and panelists during any question and answer periods we have throughout the morning. So I know last year there was so much excitement for the keynote speaker that we didn't quite get to all the questions, but we'll definitely try our best. And if they're captured in the chat, we can work it into the report. Great. So with that, we have another slide for any certified crop advisors in the audience today. You are eligible to receive 2 soil and water management continuing education units and 1 sustainability continuing education unit for attending today's forum. So you can scan the QR code on the screen using your CCA app on your smartphone to sign into the meeting. Alternatively, if you need support, you can contact Madeline Rodriguez, an OSC programs analyst, and her email is there, or the email that you can reach her at is there for the sign-in sheet, and then you can return to the CCA office by email or mail. So just give you a second to capture that QR code if you need that for any of the certified crop advisors in the crowd today. Great, and with that, we're through our housekeeping items, so I would like to give a warm welcome to Dr. Angie Strathoff, Program Director at OSCIA, to give a few welcoming remarks. So Angie, over to you.
Thanks, Bronwyn. Good morning, everyone, and welcome to the ONFARM Research Forum. The silver lining, of course, of these virtual events being that we can welcome many of you from further afield than we might otherwise. So I'd encourage you to also mention where you're joining from in the chat and keep the conversation going there. Before I begin, I want to recognize the tremendous efforts of Wilton Consulting Group, especially Bronwyn and Andrea and Krista, who have been just incredible at pulling this event together and coordinating all our guests and speakers and calming my own Zoom nerves. I want to commend the event preparation support of my OSCIA colleagues, especially Madeline Rodriguez and James Kober. So as Bronwyn mentioned, we have a packed agenda. We have a great lineup of speakers, and we're grateful to all of them for dedicating their time and expertise this morning. Can we go to the next slide? So while many of you are familiar with OnFarm, it's important to make a proper introduction to it for those of you who might just be becoming more aware of it this morning. OnFarm is a 4-year initiative that began in 2019 to focus on water quality and soil health research trials on real working farm sites across southern, central, and eastern Ontario. It's funded by the Canadian Agricultural Partnership. OSCIA delivers OnFarm on behalf of OMAFRA in partnership with the Sauble Bayfield, Maitland Valley, Lower Thames Valley, Upper Thames River, and Essex Region Conservation Authorities, as well as the Soil Resource Group, a Guelph-based agronomic consultancy. OnFarm continues to explore water quality and research questions established under the Great Lakes Agricultural Stewardship Initiative. You'll hear that referred to throughout the morning as GLASI. And it does this alongside field trials inspired by priorities identified in Ontario's soil health and conservation strategy. Next slide. So along with those soil health and water quality research studies, a third critical component of the program is engagement. How can we share the stories, results, challenges, and experiences of the farmers at those trial sites with the broader agricultural community, and especially among other farmers and decision makers? And that's what brings us here this morning. But it's also important that OnFarm is ideally just the beginning of something bigger and longer term. The establishment of a network of viable demonstration sites has always been a goal of the program. Next. So with those 3 pillars in mind, we have established an incredible network of 33 farm sites. At 8 of those sites, called our Edge of Field sites, the conservation authorities work with farmers and have installed real-time monitoring equipment whose data complements samples taken for analysis of nutrients and suspended solids and other variables. At those sites, along with the 25 paired trial soil health sites, the Soil Resource Group team measures and monitors soil health and agronomic indicators throughout the growing season, testing the effects of best management practices and comparing their impact on the trial's output, but also the economic and practical considerations that the farmers take in best management practice decision-making. Next. So you'll be hearing from me again later this morning, but for now I will invite you to enjoy the forum. Keep the conversation going in the chat window or on social media using the OnFarm hashtag. And I'll now turn it over to Andrew Jameson. Andrew is a manager with the Innovation, Engineering, and Program Delivery Unit in the Food Safety and Environment Division of OMAFRA. And along with his colleague, Anna Krola, they're just incredible champions for the OnFarm program. I'll turn it over.
Great.
Thanks.
Thanks, Angie. My job today has got twofold. I would like to welcome everybody here. I could see in the chat we've got people all the way from Kemptville, and I know we have people in the Essex region. So we're really covering the whole swath of Ontario, which is great that these virtual forums can allow us to do that. So yes, I'm Andrew Jameson. I'm the manager of the Innovation, Engineering, and Program Delivery Unit, which is within the Environmental Management Branch, and I am the one responsible for the agreement that we have with OSCIA to deliver this on-farm program, and we're very happy in terms of the delivery to date, and we're very excited about the forum today. But my other job is to welcome and introduce my Assistant Deputy Minister, Kelly McCaslin, who is the Assistant Deputy Minister for the Food Safety and Environment Division within OMAFRA, which is where our Environment Management Branch resides. So today, I'd just like to take the opportunity to thank Kelly for coming and welcoming her here, and she's going to give some opening remarks for today's forum. So I'll turn it over to Kelly. Thanks, Kelly.
Thanks, Andrew, and thanks for having me here today. I'm really happy to be kicking off this annual forum. I think it's a great opportunity to really learn about the latest on-farm findings in support of soil health and water quality. The on-farm program is key for our ministry because it supports several of our ministry initiatives, such as Ontario's Agricultural Soil Health and Conservation Strategy, as well as our Canada-Ontario Lake Erie Action Plan initiative. The impact of the on-farm program really hit home for me because I was fortunate enough to visit one of the water quality sites back in October. I visited the Huron View Demonstration Farm just outside of Clinton, Ontario. Many of you may be familiar with this site. And at the visit, I was able to see really innovative drainage practices, such as contour and control drainage system right at the site. And I want to thank again Mel Limas and Peter Johnson from the Land Improvement Contractors of Ontario, as well as Jim Gunn, the Mayor of Central Huron, and Mary Velez from Oswald Bayfield Conservation Authority. It was just an absolutely excellent tour. But it was really evident to me on the tour that the partnerships at each of the sites was really key to building stronger understanding of the best management practices and their effect on soil health and water quality on Ontario farmland. The on-farm sites really do provide that excellent bridge between the academic research and then the real world field scale experience and true results. And the bridge is really a critical stepping stone on the path from the pilot scale research and then the accepted best management practices on the farm. So our intention with OnFarm is to really provide that evidence to motivate further adoption of water quality and soil health BMPs through that on-farm knowledge sharing. And that really does complement the efforts of farmers, landowners, conservation authorities, government, other agencies, and non-government agencies to increase the adoption of BMPs. The on-farm program also focuses on cost efficacy of implementing BMPs because we know how much economics is really top of mind for farmers. So this information is really, really important to help drive the adoption of these BMPs. So personally, I'm looking forward to seeing the results and lessons learned from the on-farm programs, because I think the results are really going to help the ministry be a lot more informed, as well as more strategic in informing our own program development and thinking on important environmental stewardship initiatives, such as our Lake Erie Agricultural Demonstrating Sustainability, otherwise known as LEADS program. Finally, I really want to just say a big thank you to all the collaborators on the on-farm program. This includes our delivery partner OSCAA, the participating conservation authorities, our third-party contractors such as the Soil Resource Group, and lastly, but probably most importantly, the farm cooperators whose participation is just absolutely critical for the success of the on-farm program, because without their involvement, really on-farm wouldn't be possible. So I'm really looking forward to the session today. I think we're all going to learn a lot. And thank you again.
Wonderful. Thank you, Kelly. And thank you, Andrew and Angie, for all the opening remarks. And I really looked great to see OMAFRA's support for the on-farm research program. And most importantly, I think for the farmers that are cooperating in the program and recognizing the important role that farmers play in terms of understanding on-farm research and what best management practices can do for their operations, both economically and environmentally. So thank you for that, everybody. So we'll moving on this morning, we are very pleased to have Dr. Joshua Faulkner of the University of Vermont Extension with us this morning. He has coordinated the Farming and Climate Change Program in University of Vermont's Extension Center for Sustainable Agriculture since 2013. He will discuss on-farm water quality research and networking for climate change resiliency. So with that, thank you so much, Joshua, and I'll turn things over to you.
Thank you very much. Good to be with you. Just bear with me for just a moment while I share my screen. Let me get this full size. And I know there may be a lag, but trust you'll let me know if you can't see this. Okay. Really glad to be with you. Granted, I do wish it was in person. I really love to get up to Canada. I've had that opportunity several times. And I'd love to come to Ontario sometime. So maybe we can do that in the future. And I'd love to get to know some of the farmers and see some of the work that's happening there. It sounds really exciting. So what I want to do today, I do have a limited amount of time, and I'm aware of that. So I'm going to move it at a pretty good clip, but I want to start with kind of framing the situation in Vermont that we're facing in terms of our agriculture and the effects and the regulatory climate that we're operating in, and kind of build some foundation there, and then jump into just a kind of a high level view of the on-farm work that we're doing in Vermont with our farmers. I'm going to sprinkle in some results but I don't think I really have time to focus on that. If anyone is interested in more results, we can certainly share papers and publications. But at the same time, what I think is really the power of on-farm research is that it is local. And so the results that we have in Vermont might not necessarily be applicable to your situation on your farms in Ontario. So in some ways, I think the results are less important than the process and the relationships that we have and have built with doing our on-farm programming here in Vermont. Okay, so I'm going to jump right in. So Vermont is really dominated by dairy. We're known for that. About 3/4 of our ag sales come from dairy. They like to say here that no state is more dependent upon one single commodity than Vermont is upon dairy. And so that kind of helps you understand the types of farms that we're working with. A lot of corn silage, hay, alfalfa rotations. And the other important factor for us is geographical. And I'm showing the Lake Champlain Valley on the right-hand side of your screen. Lake Champlain, a very large body, not as big as the Great Lakes, but a very important body, freshwater body for us here in Vermont in terms of recreation and economic generation, is on the western border of Vermont. And I show this because all the yellow you see on that map, that's our farmland, that's our agricultural land use. And so our ag is really pushed up against this really important body of fresh water. And as you might imagine, that can lead to some issues around water quality. The other major factor for us here is really a changing climate. When we look at the northeastern U.S. As a whole, over the past century, we've seen an increase of about 4 inches in that 100 years in annual precipitation. But when you look at the Vermont specific data and you kind of look at our local data, you see a very different story. And that's what I'm showing on the upper left-hand side of your screen. In the past 30 years, we've seen increases in annual average precipitation here of 5 to 7 to up to 9 inches in 30 years. And so 4 inches over 100 years, that's multiple generations on a farm. But 9 inches in 30 years, that could be one single generation on a farm. And that is a big deal. And our farmers are really on their heels trying to understand and adapt to this, especially around soil management and some of the water quality implications with this. The other important thing to mention here related to the changing climate is that it's not just that we're getting wetter, it's that the patterns of precipitation are changing. And here you see in the Northeast US, we've seen this 74% increase in very heavy precipitation events in the past 50 years or so. And what I think is really interesting about this is that when I'm on farms, it really doesn't matter where someone's politics are, where they are with accepting a climate change and all that. Farmers talk about how they notice this is changing. These increased storms are really a challenge for them, and they're trying to figure out how to deal with their soils because it's so much different than when they started farming or when they were a kid growing up on their parents' farm. And of course, these have, like I said, these have implications for the soils on our farm. This is gully erosion from one single storm event near Burlington, Vermont in 2014. And I apologize, I'm standing there with a silly grin on my face because as a soil and water engineer, I had really only seen gullies like this in textbooks in college. And so to be, really to see this firsthand was kind of a really sad thing, but really a special thing too, to witness this, what, we really only seen widespread in the Dust Bowl in the United States in our history. And I'm about 6'3", And so that gully is 2.5 to 3 inches deep, 2.5 to 3 feet deep, sorry. And it extends beyond that frame. So a real tragedy for the farm that these extreme events are leading to this amount of soil loss. And then to bring it all back together here around our lake is that this soil, of course, is a tragedy when it's lost from the farm, but then it, of course, ends up somewhere, right? And ends up in downstream receiving waters. And this is an aerial image that NASA captured following Tropical Storm Irene after it came up through New England and really did a lot of damage to farms, especially in the floodplains. And this is the river just belching out all that sediment into the Long Island Sound down near New York City. And, you know, all of this sediment is not from farms, but a lot of it is, and it carries nutrients with it. We know that phosphorus, of course, binds tightly onto sediment, and so it goes along with the soil. And this is not just in the Connecticut River, but of course on the western half of the state where I do most of my work, it ends up in Lake Champlain, and we have what's called a TMDL, a total maximum daily load, which is a pollution diet for phosphorus, is kind of a simple way to think about that, that the federal EPA has instituted on our lake, and said that we need to reduce the phosphorus loading to that lake by 36%. And agriculture is the primary source of that phosphorus entering the lake. So you can see how our work here is really cut out for us. We have, you know, this nearby lake, which is being affected by nutrients. Most of those nutrients are coming from agriculture, or we're the primary source. And then we have climate change, which is not making this any easier for us. It's kind of making it a really hard row to hoe. So that's our situation here. And now I want to jump into our work that we've been doing over the past 7 to 8 years. Actually, I'll say we really got into this in the past 4 years, is this on-farm research, which has been a really exciting adventure. And I'm going to kind of go through it here, and I ask you to humor me on my analogy here, that I think about our work as one of those Russian dolls, where we have lots of work and it's layered, and it's really, the work is very similar, but it happens at different scales. So we have work that's happening at the watershed scale, work that's happening at the field scale, work that's happening at plot scales. All of that is on farm, and it has many of the same questions we're asking at the large scale, we're asking at the medium scale, the small scale, et cetera, et cetera. So this is kind of the way I kind of want to walk through this today, is that we're looking at different layers, but it's many of the same questions and much of the same work and the processes, the physical and chemical cycling that we're looking at with this work. So I'll start at the watershed scale, and that's our biggest wooden doll there. And so we have a project that started in 2019, and this was focused on the long-term evaluation of conservation practices at the watershed scale. And that's really key there, is that you would think that we would have a really good handle on this, but you know, and maybe we do in some parts of the country or in parts of Canada, but we don't have that information for our particular setting here in Vermont, for our soils, our climate, our farming systems. And so we need to answer that if we're going to advance this water quality work in Lake Champlain Basin. So as part of this, working with federal and state partners, we installed flow gauges on two main watersheds in one of our intensive agricultural counties. We sample base flow and storm samples for nutrients and sediment at those locations. And then the piece that I think really brings this back to the work with farmers on farms is that water quality work is really important in those rivers and channels. But what I think is just as important, or maybe more important, is the work we need to do out on the farms in those watersheds building relationships and understanding, documenting what conservation practices, what land use is occurring, management practices on every single field, on every single farm within those watersheds. And that is a tremendous undertaking and requires a lot of relationship building and trust with our farmers in those watersheds. So just to show those two watersheds to you to kind of help us understand what I'm talking about here. Here's one of the watersheds. This is our treatment watershed. So I should stop for a second and explain. A lot of our work is done with a paired watershed approach. So we have a treatment watershed and a control watershed, and we monitor those for what we call a calibration period to understand their relationship. And then we move into a treatment period, which is where we actually do something different. We apply that BMP on our treatment watershed, and then we monitor it into the future. And so this work at the watershed scale is done the same way as it is done at the field scale. So this is our treatment watershed. It's a little over 15,000 acres, and it's 75% agricultural land use. So you might imagine there are a lot of farms and a lot of fields in that watershed that we have to go out and document and work with the farmers on what's happening there. And our control watershed, just north of the treatment watershed, this is about 22,000 acres and over 50% agriculture. So again, lots of fields and lots of farms to work with there. The other piece of this at the watershed scale that we're doing is measuring soil health in both of those watersheds on lots of fields. And this past year was our baseline measurement period for the soil health measurements. And what we're trying to understand is that, again, at that watershed scale, is there a relationship between broad soil health indicators and water quality at the watershed outlet? And so we've done this past year, and we'll do this again in 3 years or 5 years from now and on into the future to see if we're starting to see a relationship between those two pieces of data. This is exciting because I think for the farmers that we work with, because they also get the results of those soil health tests delivered back to them, which I think is a really nice bonus for them cooperating with us on this work. And then this past summer, we also added 30 centimeter cores on some of our fields to understand the carbon stocks that exist within the soils on those farms. And that's kind of a buzz. Everyone's really excited to understand how much carbon are we storing in our soils, and is that changing over time. So now we're gonna go down to the next smallest Russian doll size here and talk about our field scale research. And we have a lot of this. I was really excited to see the map that was shown just a few minutes ago. You have a lot of this happening in Ontario. I don't think we have quite that much, but we have just under 20 stations deployed around the state. We are monitoring flows in tile drainage. We're monitoring flows in surface runoff. And I'm just showing some of the approaches we use here in these images. In the upper left-hand corner of your screen, that's one of our tile drainage monitoring stations where to avoid wintertime freezing impacts and avoid submergence of our outlets, we back up into the field, dig a manhole, and put our monitoring equipment on the tile main in a manhole about 4 feet underground so it doesn't freeze. And there's pictures of flumes and our monitoring sheds. All of these are solar powered and require a good amount of work to keep these running. We have a couple of fields where we're doing not just surface runoff, but surface runoff paired with tile drainage runoff within the same portions of that field, so that we can understand what the combination of the tile drainage and the surface runoff contribute to phosphorus loading from that field. What's key for this, and what with working with my extension partners, This takes a lot of cooperation, as I'm sure you know there, with the farmers that are willing to let us come onto their farms and do this work. And some of this work is fairly new. It takes about 2 years for us to go through a calibration period before we can really move into that treatment period and apply that BMP that we're interested in understanding the effects of it. And so, you know, that's really the end goal here, but we're getting valuable information as we go. And just wanted to quickly show you some of the results from one field where we've been monitoring. We have 1 year's worth of data to show, and this is tiled phosphorus export from a tile drainage outlet from a field. And so we can see that over the course of almost a year, we continuously measured and determined that we had about 1.1 pounds per acre per year of phosphorus leaving this field, which is really helpful for us to understand where we fall in the literature around what's the range of phosphorus that is expected to be leaving a corn silage field in tile drainage, and we're well within that range. So that's very helpful for us to know, but we'll continue to monitor this and compare this to its pair as we implement BMPs in the future. And then one of our primary challenges, I'm sure you face the same thing, is that we have this wintertime condition that is really just the thorn in our side of most of our monitoring efforts, and trying to accurately capture and perform monitoring during the winter season. And it's really easy just to kind of say, oh, we're just going to stay inside this winter and focus on paperwork and writing papers. But we believe that the winter time is really a very important period for nutrient export, nutrient loss from our fields. So we do everything we can to try to prepare to capture snowmelt events and rain on snow events, things like that. We have heaters installed on our stations, and we're just trying to do the best we can, but our winters, as yours, can be very, very dark and cold. So some of the results from our field scale work, just kind of sample results to show you what type of information we're generating. Here's a couple examples from recent papers that we've published. One study, we did paired watershed work on aerating hayfields before surface application of manure. We saw that we reduced nutrient concentrations in runoff, but the aeration also increased the volume of runoff. So we saw no reduction in massive nutrients in that runoff. And so that's helped to inform our policymakers and folks in the state making cost sharing certain programs on farms. We've also done some work showing that soil greenhouse gas emissions, when we inject manure, can potentially outweigh carbon storage benefits from some other soil health practices on those fields. So it's really helpful for us to just understand that there could be some trade-offs with some of our water quality practices. We may see water quality improvements, but there could be some negatives when it comes to greenhouse gas emissions. And then a new project that we're starting up this past year that I'm very excited about is this one, the Dairy Soil and Water Regeneration Project. And this is where this is kind of an aerial view of one of our fields where we're comparing the control and treatment side of the field. And we've divided that field in half using an existing ditch and a barrier down the middle of that ditch. And we are not just monitoring what happens as a result of the infield practices, cover cropping and no-till, a suite of soil health management practices, but we're also monitoring some edge of field practices where we're filtering phosphorus from the tile drainage flow, and we're filtering phosphorus in the ditch that leaves that field. So we're able to evaluate what happens in the field and then what happens with our BMPs at the edge of field as well. And just a list of BMPs that we're evaluating in our control and treatment field. And here is another example where we're coupling this with greenhouse gas emission monitoring. I'm showing a chamber there in the upper left-hand side of your screen. And we're doing lots of soil health measurements in these fields as well, deep cores to understand carbon stocks and just general soil health indicators in addition to that. And then another new project, we're fortunate in Vermont to become part of the Discovery Farms Network, which some of you may be familiar with, which Wisconsin and Minnesota and North Dakota and some other states have this really cool program where they work with private farmers to monitor runoff on their fields, and we're doing the same thing here. And in our situation here, we are actually monitoring 4 large plots on a single farm field. 2 of those plots are drained and 2 of those are undrained. You can see those orange lines and black lines are the tile lines in our drained plots. And then we have 2 on either side of those that are undrained. So with this work, we'll be able to help kind of chip away at that question of not just what's the effect of BMPs, but what's the overall effect of tile drainage in conjunction with BMPs on water quality. We have a lot of interest here in tile drainage because of the effects of climate change. So it's a really hot topic in our state. And just an image of that Discovery Acres site where we have these monitoring huts spread throughout the field. And this, as you might imagine, this requires a high level of cooperation with the farmer so that they can still produce a crop on this field and work around our monitoring equipment. We couldn't do this without the farmers wanting to work with us and really curious about the information that we're generating. And then our next level is small plot work, and this is all done on private farms as well. This is a rainfall simulator setup. Inside that big marshmallow looking structure, there's a rainfall nozzle, and we are actually in this instance we are producing rainstorms on a 2 meter by 2 meter square of ground that had grassland manure injector used to apply the manure on this field. And so we've studied runoff from these from surface application versus injected in grasslands, and then a control as well. So this has been really exciting complement to do again some of the same work at the plot scale that we're doing at the field scale. And then what I call our really small plot scale. This is where we've gone in at really just point locations within farm fields and installed what we call lacimeters, so we can measure what leaches down through the soil profile on working farms. And we've been able to generate some really interesting and illuminating information by using these devices. And these are devices where we install into a field, and then we bury all our sampling lines to the edge of the field so that the farmer can really farm this field as they would and as if we weren't even there. So again, lots of cooperation with the farmer to do this type of work as well. And just to finish up here, when everything works the way it should, and it does sometimes, and sometimes it doesn't, but all of this monitoring and practice evaluation at the multiple scales is really powerful information. And we work with modelers, and we work with folks who are improving our on-farm management tools, and those can inform our policy and our program folks, both at the state and the federal level here in Vermont, the USDA and our Vermont Agency of Agriculture, and hopefully get some action and some change to help farmers with cost share and technical assistance programs. But my last point is here that it takes time. It takes a lot of time, and that's something policymakers don't always want to hear. They want to hear they fund a program in the spring, and we go through a growing season, and next fall they'll have some answers, and it's just not that fast. So it takes, it really, for these paired watershed studies, we're looking at 5 years minimum to get good results. Okay, so I'm going to end there, and I hope we have a few minutes left for questions.
Yeah, wonderful. Thank you, Joshua. That was such an interesting presentation and overview of the work you're doing in Vermont. So really appreciate you being here with us today. And I do have a question in the chat, and I think another one is coming in, and we have a couple minutes, so I'll get to this one. It's from Dave Bray. He's curious about your comment about aeration of the hay field. So how does manure aeration increase the volume of runoff? And my chat, just if you could maybe just comment a little bit on that and how you define aeration.
Sure. So this is a great, so we use an airway aerator. And this is a really good example of where local context matters for our monitoring work. We are on heavy clay soils. And what we think is that the aeration occurred if soils are not dry enough, especially in these clays, that the aerator would actually do some fracturing of the soil where it would kind of loosen things up, where it might increase infiltration. If we use that aerator when soils are even just a little bit moist, we believe that we're actually increasing soil compaction, and the knife is just slicing into the soil. It's not actually creating any, it's not opening up the soil any, if you will. And so in our soils, this is a risky operation because of how these clays respond to additional traffic or an additional operation. So that's what we think was happening there.
Okay, great, thanks. And yeah, that's such an important point about local context mattering in the type of soils you're working with. Another question about when you speak to using a whole watershed as a BMP treatment, what level of buy-in have you seen from those farmers, or what % of the area have you been able to cover?
Yeah, sure. Great question. And so we are transitioning this year. We're just exiting our calibration period this year. We have really good relationships with our farmers. We selected our watersheds because of those relationships. We expect to have good buy-in. I can't say that we've had it yet because we're just now starting down that road. But we're also working with the agencies that carry the financial assistance, and they're cooperating right along with us. So we do have some incentives for those farmers to accelerate conservation practices within the treatment watershed. Great question. Check back with me in a few years and I'll let you know more.
No, that's great. There were some comments in the chat too about that, you know, the bureaucracy of trying to get different agencies and levels of government to cooperate, and some context is slightly different between the US and Canada in that regard. But yeah, it's always interesting to see how you can pull those collaborations together. And there is one last question in terms of what do you do to build those relationships? Like, is there something you're out there all the time talking to people, or how does that work in your world?
Yeah, I mean, it is, there's no secret, you know, sauce there. It is really on farms, talking to farmers, developing trust. And I hope we'll get a chance to talk about this in the panel later today, but, you know, working with our local extension folks, myself, and people who have been in those areas in those counties for years and years and years, and just, you know, developing trust and having those go hand in hand with those people when we visit those farms.
Yeah, such an important point. Awesome. Well, thank you so much. And it's great you're going to be able to stay with us for the morning, and you are coming back in the later panel after our concurrent sessions. So everyone can stay tuned and save up some questions for you for that time in our program this morning. So with that, thank you, Joshua.